Today I'm going to discuss the justification for storage area networks, and then I'm going to talk about storage area network technology. And with that, let's go ahead and begin this session. Of course, I'm going to begin with justifications for storage area networks. There have been several factors that have led to the increased demand for data storage. One of them has been the dramatic decrease in the actual cost of data storage. It actually costs us less now for storage on a per gigabyte basis than it has in the past. What has happened is that as the cost of storage has decreased, the demand for storage has increased dramatically. Businesses are now generating and analyzing huge amounts of data in an effort to create a competitive advantage. Think big data. I'm sure you've heard about big data recently. Or this increase in data collection has led to an increased demand for storage capacity. Another factor is that as the demand for data has increased, it has needed to be more available, which means that there has been a need to be able to access that data from anywhere, and the accessibility is needed to be increased as well, including from non-standard devices. A storage area network, or SAN, can be a solution to the need for both storage capacity and high availability. There are several advantages to the storage area network. First off is scalability. The amount of data that is being generated today is huge. This has led to a need to store that data. The SAN is more scalable than other options. As your storage needs increase, the capacity of the SAN can be easily increased to meet that storage need. Then there's data availability. The demand has also increased for that data to be available at any time from anywhere, and a SAN can play a vital role in creating that accessibility. One of the most popular implementations of a SAN is to deploy it as part of a cloud computing solution. This increases the availability of that data that's being stored on the SAN. And finally, there's optimization. As the requirements to store data are removed from application servers, those servers can then be optimized to run those applications much more efficiently. At the same time, data storage is also optimized. It's time now to discuss some SAN technology. The storage area network, or SAN, and the network attached storage, or NAS, often get confused with one another, but they are different. The SAN is an actual network of devices that have the sole purpose of storing data efficiently. On the other hand, the NAS is a specifically designed network appliance that has been configured to store data more efficiently than standard storage methods. The difference is that a NAS is a data storage appliance that is placed on a network, while a SAN is a network of data storage devices. It is not uncommon for a SAN to contain multiple NAS devices. With all of that data storage capabilities, several technologies have been developed to ease the transmission of that data. The first one that we're going to discuss is fiber channel, or FC. Fiber channel is a high-speed network technology that was originally developed to operate over fiber optic cables only. Since its introduction, the standards have been modified to allow the use of copper cabling in conjunction with fiber optic cabling. Fiber channel is commonly used to connect to SANs. When fiber channel is implemented, it uses the Fiber Channel Protocol, or FCP, as its transport protocol to transmit Iscsi commands. So it transmits small computer system interface commands to storage devices, as in the NAS appliances. So a SAN implements FCP as opposed to TCP as its transport protocol when fiber channel is used. Another technology that was developed was Internet Iscsi, or Iscsi. Iscsi is an IP-based networking standard that is used to connect data storage facilities and SANs. Iscsi allows for SCSI commands and processes to take place over longer distances than the original SCSI implementation. Jumbo frames are also allowed within the SAN environment. Jumbo frames allow for greater throughput of data by allowing up to 9,000 bytes of data to be in a single frame. This can greatly increase the efficiency of a SAN. As a comparison, the standard frame on an Ethernet network can only be a maximum of 1,500 bytes. Now that concludes this session on storage area networks. I talked about the justification for storage area networks, and then I concluded with a brief discussion on some SAN technology.